Hi, this is Miss Harder, and we are doing 6.2.2 dilations and similar figures. In this particular lesson, we are going to be moving out of multiplying the dilations. We are going to focus on basically dividing dilations. So for 6-52, which we're on right now, you probably have the paper in front of you. We also have a Desmos activity, but I actually have plotted our points for us, and we are actually going to just draw it out. So for A, it's going to be -4, 1, 2, 3, 4, and up 4, 1, 2, 3, 4. So this is A, and then B is over 4 on the positive, 1, 2, 3, 4, and then up 8, 1, 2, 3, 4, 5, 6, 7, 8, B. And then C is over here, 1, 2, 3, 4, 5, 6, 7, 8, and then up 4, 1, 2, 3, 4, C. And then D is 6, 1, 2, 3, 4, 5, 6, and then down 4, 1, 2, 3, 4. And this is D. Now I'm going to put it all together. For those parents who are watching, you might ask yourself, well, oh my God, why are we drawing out each and every one? It kind of gives the student a moment to understand the length of each of the quadrilaterals, and then actually drawing it out for themselves helps them to have muscle memory on how to do this geometry. All right, so let's take a look. Charlie multiplied each coordinates of the vertices on a shape by 4 to create the dilated shape on the right, which is this shape. If Charlie multiplied to find the shape, what operation would we undo and why? Well, we've talked about this. We're going to divide it, but it's also called, we are going to reduce it, a reduction, as it is. So I'm just going to put reduce. Okay. And what we are going to do is actually, we are going to multiply by 1/4, or you can think about it as dividing by 4. So in this moment, the A now reverts back. See, these would be the A1s because the original was smaller, correct? But in this moment, we're going to have a -1 and 4. Oh, excuse me, a -1 and 1. And then this is going to be 1 and 2. The C is 2 and 1, and then the 6, hold on one second. All right, so for the 4 and 4, it's going to be, and this is -4. It's going to be, once again, 1 and then -1. So when we draw this out, this is actually the original, the OG, if you want to say that, is going to be -1 and up 1, and over 1 and up 2, and then over 2, 1, 2, and up 1, and then 1 and -1. So this is your original shape. Okay, great. Now, Alana was also working with dilations in 6-53, so let's move to a new page. Right, and once again, when drawing this out, you are going to do your straightest line because we are trying to be exact, correct? We're going to do our straightest line here. Boom, boom, boom. And she wants to know what would happen if she would multiply each coordinate by 1/3. So here are our coordinates. We've got -1 and 1, Okay, we've got -1 and 1, 1 and 2, and then the last one is 2 and -1. All right, so I'm just going to plot this -1 and 1, 1 and 1, -1 and, oh, excuse me. Even Harder's not reading the negatives this morning. -1 and 1, or 1 and 2, and then -2 and down 1. So we have this little itty bitty shape. Can you imagine us making it even smaller? What's going to happen if we multiply by 1/3 in our scale factor? Remember, once again, this is our scale factor. Well, if we do multiply it, it's going to be a -1/3 and a -1/3. And this one's going to be a -1/3 and a 1/3. Okay, this one's going to be 1/3. And then this one's going to be 2/3. And this one's going to be 2/3. And this one is going to be 1/3. Now, am I going to have you graph each and every one of these little itty bitty things? Well, we could kind of do it, right? This would be a -1/3 here and then down 1/3. So it would be really itty bitty, right? So we're going out a third and then going up 2/3 and out 2/3 and then down a third. So it would look like this. I'm laughing because the computer can do it better. So we dilated it and it is small. You can look at it. What did you do to get each coordinate? Well, we just multiplied it by a third and it made it a third because it's 1. Okay. So with your team, you are going to answer these questions for 6-54. Now, on 6-55, I'm going to do a new one because each one of these shapes in itself takes more time, right? So this is what we are going to do. I'm sorry, the cord is in my way. We're going to get this really up here. Right. Okay. So changing shape. When you multiplied each coordinate of the shape by the same constant, you saw that sometimes the shape became smaller and sometimes became larger in this chapter. You move shapes on the graph without changing shapes. And what other ways can you change a shape? Hold on just a second. Okay. So on this one, we've got, let's just take a look. We've got a triangle, right? We've got P is 0 and 2, 0 and 2. So we have P. And then we have Q, which is 6 and 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. And that's Q. And then I've got R, which is 4 and 0. 1, 2, 3, 4, and 0. And then S is at, here's S, and then this is R. Perfect. I really appreciate that they label them. I don't like it when they don't. It just kind of complicates our lives a little bit. All right, so I've got P that is at 2 and 0, 0 and 2, right? S is at 0 and 0. Q is at 6 and 7. And then R is at 4 and 0. So when you take a look, they ask you, can you predict what this is going to look like? Okay, So they want you to multiply it by 4. And then, so let's just do some things. So we're not going to draw each and every one of these out, but let's just take a look. You cannot draw these things, and you can just multiply them out. The first thing, our first scale factor is going to be 4. So that's the first bit of math that we're going to do. I'm going to draw out the 4 so you can see it. So let me get this so everybody can see it. Scale factor of 4. So this remains, P remains 0 and then 8. Okay. This one remains 0 and 0, right? 6 and 7 become 4 times 6 is 24, and then this is going to be 28. So actually we can't because we don't have the room. And then this one is going to be 16 and 0. Okay. Now, what are they're also asking us, they're saying to us, hey, what is it going to be like if you multiplied just the x coordinates by 3? Well, we would go back to the original, right? Here's our original. And what's it going to look like when the scale factor x equals 3? You're just multiplying by 3, right? I guess it would be 3x, but here, we'll do that. We'll do 3x. So we're just doing, so P is now going to equal 0 and 2, right? S is still going to be the same, 0 and 0. 6, or Q, is going to be 18 and 7, and then R is going to equal 12 and 0. Okay, so that's a multiple of 3. Now, what happens when you multiply the x's, okay, when you go times 2y? So when we look at that, we'll keep the x coordinates the same, right, on this one. And this will be 0 and 4. The s will still be 0 and 0, of course. Okay, then we've got 18 and 14, and then we've got 12 and 0. So that's it. Now, we would draw these out. You can if you want on the Desmos, but that's pretty much the end of this lesson. But just notice that these are your scale factors right here. And when you multiply them out, you have to make sure that you're either doing a whole number, you know, or you're doing a fraction. All right, have a good day while I'm gone. Good luck.